Okay, so this is the solutions to the first set of problems that I put out on the first day of school, the kind of pre-cal review topics. All right, so the first one is asking about this function f equaling 6x squared, 6x, and negative 12. And just a very simple question, what are the zeros of f? So, really, if we're going to find out where a polynomial is equal to 0, we're going to want to factor it and figure out where each of the factors are equal to 0, because that would make the whole thing multiply to 0. So, what I'm going to do is I'm going to notice that I have 6, 6, and 12, and that's generally going to be the case in this course. Like, if there's a leading coefficient, it's probably going to be something that you can factor out of all three. Maybe only once or twice can I think of AP calculus questions where you had to factor something like 2x squared plus, say x minus 1, or that might not even work. But, one of those where you would have to use the AC method. But generally in this class, those are you can just kind of look at them and figure them out. So what we're going to do is we're going to factor this thing first by taking out the 6. And then by splitting this thing up, that's going to be x plus 2 times x minus 1. So that means that f of x is equal to 0 whenever any of these factors equal 0. Now this could be from x plus 2 equaling 0. It could be from x minus 1 equaling 0. Or it could be from 6 equaling 0, but that's not possible. Okay, so that doesn't contribute any solutions to us. Okay, that's why that doesn't help you. All right, that's it. And then the second question is going to kind of play off the same type of function that wants to be factored, but I think I probably just threw in, 2 more powers of x or t. Okay, so g of t is going to be 6x to the 4. Oh, and then of course I switch the sign. Minus 6t to the third. That would be minus 12t squared. Okay, and we want to know where this is positive and negative, and there's generally 2 ways to do it. If it's something that you look at and you think you can sketch the graph of by factoring and just looking at the zeros and their multiplicities, then you go ahead and do that. If not, then what you're going to do is you're going to find the zeros and make a sign chart of these things for you. So what I'm going to do is I'm going to start by factorizing it. Actually, maybe I'll take out the 6 and the t squared that's common to all 3 terms. That would be smart. And I would have to multiply that by negative 2. Okay. So, and then I can go ahead and say, well, that's where 6t squared times t minus 2 times t plus 1. Okay, now I know that this thing is equal to 0 whenever 6t squared is equal to 0. Now that only happens when t is equal to 0, when t is equal to 2, or when t is equal to negative 1. So those are the places where the sign could potentially change. Let me kind of scroll this down a little bit. Okay, so what I'm going to do is I'm going to actually draw a sketch of the graph of g, so we can figure out where it's positive and negative. All right, so I've got negative 1, 0, and 2 are my zeros. And you'll see, like, I've got graph paper, and this is going to kind of be not to scale, but I always find that it's easiest to sketch these graphs if you evenly space the zeros. Don't try to draw it to scale, because then it'll just end up like, you might have to draw it small and come to the wrong conclusion. So it's going to be negative 1, that's going to be 0, and that's going to be 2. And that's enough space for me to draw my graph. This is a 4th degree polynomial with a positive leading coefficient, so in some sense, I know it's going to look kind of like this, right? I know that at negative 1 and at positive 2, that's a single root, so it's going to pass through confidently. So it's going to go kind of like this. And then, I don't know how far it's going to go. How far it's going to go is really a calculus idea. But then at t equals 0, I'm going to have a balance because of the even multiplicity. So I'm just going to draw it like that. I'll draw it symmetric because, you know, stands a pretty good chance of looking like that. Not guaranteed. Again, how far this goes down and where between 0 and 2 it hits that little minimum, that's kind of the calculus stuff that you're going to learn how to do over the course of the next few weeks. Okay, alternatively, maybe you were not good at coming up with this. Okay, I know that some people that wasn't included in their pre-cal or Algebra 2 class. I think that's a shame because this is any of the actual graphing on graph paper. I think is a waste of time now because we've got a calculator that can graph it way better than you can by hand, much faster. Or we can just quickly draw a sketch and know everything that we need to know, right? I'm going to say G is positive, which is to say G of t is greater than 0 when t is less than -1 or when t is greater than 2. Okay. G of t is negative when t is between -1 and 0, or t is between 0 and 2. Now, in this class especially, if you were to say just from -1 to 2 because it touched there and it wasn't positive, it didn't, you know, this wouldn't necessarily be true, but this kind of, like, if you made it less than or equal to, nobody ever is going to, you know, pick at you on the difference between those things. The boundary cases we don't care about in this class. That's discussion for a different type of class. So I'm going to also mention that you could do this a different way. And I made sure to choose these numbers this way for a reason, because if you have the numbers close to each other, that this method can be less pleasant. Okay, so what I'm going to do is I'm going to make another number line, just like this. Except on this one, I'm not going to draw a picture of the graph. You know, something like here, right? -1, 0, 2. And so what we need to do is we're going to say this is kind of a chart of G of t. Well, G of t is equivalent to 6t squared times t minus 2 times t plus 1. So what we're going to do is we're going to choose a representative over here. Like maybe, you know, between 0 and 2. Let's start with that. Really obvious number to choose between 0 and 2 is 1. Okay, so I choose 1 as my test value, because these are the only places that the sign can change on a polynomial, is at the zeros, based on their continuity and some other factors. But that's kind of a more pre-calculus argument to make, so I'm not going to really talk about that. So this is 6 times t squared is 6 times 1 is positive, times 1 minus 2 is negative, times 1 plus 1 is positive. So I've got a positive times a negative times a positive means this is negative. Okay, something bigger than 2. Well, no restriction on how big it could be, so I'll choose something like 100, right? So that when I plug it in, everything's going to be positive, right? I can't, 100 minus 2 is still positive, 100 plus 1, 100 squared, all sounds like positive numbers. So it's all positive, so that means it's going to be positive here. Okay, maybe you know that since you have a double root here, it's not going to change the behavior. There's not going to be a sign change, but you know, I'll just show you why that's the case. Because at 0, it's to the squared, right? If you choose a number less than 0 and greater than -1, like -1/2, and that's kind of why I don't like this method, is because if the integer zeros are consecutive, then it makes it really annoying sometimes to put in a fraction in there. So what we're going to do instead is we're going to use -1/2, and I'm going to say 6 times -1/2 squared. Well, that's going to be 6 times 1/4 is a positive number. Then when I take -1/2 and I subtract 2, I have negative, and -1/2 plus 1 is going to be positive. And if you think about it, what we did when we switched from 1 to -1/2 is we just changed this factor. We went over the 0. We crossed the 0 here to see what would happen. Well, since it was squared, take a positive number and you square it, take a negative number and you square it. It doesn't really matter. Okay, so, and then this is also negative. And so over here, you choose something less than -1, like, I don't know, maybe -10. Positive, negative, negative. So that's going to be, and that's positive. Now, that's a lot faster to do when you don't have to explain it to somebody else while you're doing it. But I find that this can be a little error prone. But if you came from AB, that was definitely the way you did it for, there's a lot of things that we're going to have to determine whether positive and negative in this class. And this is how you did it in AB. And if you're comfortable with this, you keep doing that. If you learned how to do this in pre-cal, produce a little sketch, and you felt really good about that, then you keep doing that. I will say the weakness for this one is it only works on something that's like a polynomial that you can factorize and graph pretty simply. If I were to divide this by, t plus 3, all of a sudden you don't know what this looks like. And you have to use a sign chart. And I'll tell you more about that when the appropriate time comes, when it's actually relevant. But, okay, for the third one, all right. Ooh, man. 2 line segments in a quarter circle. I'm going to do my best to replicate this graph, and in general I probably wouldn't even bother with this, but since I do have grid paper, I'm just going to try. So it goes from -2, 1 to 0, -1 up to 2, 3, and then it's a quarter circle down to 5, 0, 2, 3. Okay, and it looks pretty good. This is the graph of y equals h of x, and I'm not on the screen. Here we go. So this is the graph of h. All right. So the first part they asked us where it was positive and decreasing, I think. Let me make sure that's true. That's another thing that we're going to have to do this year, look at a graph and tell where it's positive and decreasing. Now, you have to do the calculus step before getting to that, but this is the stuff that is at your level right now. Well, h is positive anytime the graph is above the x-axis, right? H is the y value, y equals h of x. So h is positive for all of here and all of here. Okay, basically just not positive between -1 and what looks to be positive 1/2. Based on the slope and stuff, even though my drawing isn't that great. Okay, so positive is just like here and here. Okay, well, decreasing means getting smaller, and we'll be a lot more specific about what I mean by increasing, decreasing, and concavity, and all sorts of stuff. But decreasing does mean going down, right, as time goes on. So I'm going to label here, I am decreasing. Here I'm increasing, right? It's going up. So it's going to be decreasing here as well. And then, if I said, well, positive was what I kind of annotated in red, and decreasing was what I colored in blue. It's positive and decreasing where they overlap, so that's -2 to -1. Union, what is this? 2 to 5. Okay, so notice I wrote it as an interval here. I wrote them as inequalities up above. In this class, it does not matter. Okay. Part B is to find the area of the region enclosed by the x, in the first quadrant enclosed by the x-axis in the graph of h. So what I'm going to do is I'm going to reproduce this graph, but only the first quadrant. I'm going to do it over here so we don't get distracted. I really only care about the first quadrant, right? So I'm going to say it starts here at 1/2, and then it goes up to 2, 3. So 2, 3. And then there is a quarter circle all the way down to here. So the thing about drawing a circle is that you know that at the sides it's vertical and at the top and bottom it's horizontal. So I kind of start off with that. And then I make sure that by the time I arrive, I'm definitely going sideways. And that looks like the axis got curved, but that's it. Okay, this is the graph of H and the x-axis. This is the region we're talking about here, right? Okay, so what we need to do is we need to split this off into two subregions, right? What we're going to do is we're going to go over here, and we're going to find the area of this triangle. Well, you know how to do that. You know, one of our nice geometry teachers taught you how to do that a couple years ago. And so the height of the triangle is 3, the base is 1.5. So total area, just going to use a pencil. It's going to be equal to the area of the triangle, which is 1/2, times the base, which is 1.5, times the height, which is 3, plus a quarter circle. Now, this isn't actually the area of the quarter circle, right? What you do is think about it in terms of subtraction. What we need to do is we need to find the area of the quarter circle and subtract it from this square area here. So it's going to be 9 minus a quarter of the area of this circle that has radius 3. Okay, and that's a pretty common thing for us to have to do in this class. Now, you need to get to the point where you know you need to take the area under the curve, but frequently we have to apply geometry formulas to this. All right, so plus, it's going to be 9 minus, right, the whole square of 3 by 3 is 9, minus the quarter circle. So it's a quarter of pi times r squared. Well, r is 3 in this case, so I've got 9/4 plus 9 minus 9 pi over 4. And in this class, we can just stop there. And that's a number that represents the area under the curve. It's an exact answer also, and so we really like those. If you're going to report a decimal number, it's got to be 3 decimals. No questions about significant figures or any questions at all. You report 3 decimals. Even if it's like 2.4, you need to write 2.400 in this class. It's just kind of the standard. Okay, so that's number 3. I should be done with this pretty soon. I've got class starting for too long. Let's scroll this out. Okay, number 4. And these, I think, yeah, this should go pretty fast. Make sure I'm on the screen. No, I'm not. All right, so what we're going to do is what values of t make cosine of t equal to negative root 3 over 2, right? Yeah. And this is one that I need you to be able to solve like pretty fast in your head, ideally. Because you know that cosine is kind of like the horizontal coordinate on the unit circle. And negative root 3 over 2 is pretty far over. It's not all the way over, that's negative 1, right? But a half is pretty close. That's why I always draw the diagram. Half, root 2 over 2, root 3 over 2, 1. Because 1 is root 4 over 2, right? So I've got root 3 over 2, and I know that it's everything that has that same x level because it's the cosine of t equals root 3 over 2. So I'm kind of scanning up and down. There I found one, and there I found another one. And this to me looks like, you know, it's almost all the way to pi. It's just off by pi over 6. So t is going to be almost pi and just a little more than pi. Those are ones that if you have to go and look it up off of your unit circle reference chart, first of all, if we ever go back in person, you're going to be in trouble because we don't use those. Okay, we've tried to tell the pre-calculus teachers to stop letting you use those on the quizzes in the tests, but they don't listen. you can't use a reference sheet in this class. Every year I get that question. And at this point, if we're going with shortened exams, if you have to look this up or have to spend a bunch of time on this, that's just going to be time you're not going to spend working on a different calculus problem. You're going to be sacrificing, points off your grade to go look up trig facts. So you just need to know them quickly. Okay, we don't do cosine of 9 pi over 2. You don't have to worry about that. I've never seen that. Or sine of negative, say, 17 pi over 4. Something crazy like that. We don't do that. Or if we did, you'd just have a calculator for it. So number 5. We're going to solve backwards for a different variable. Really what this is solving for an inverse function in a really sensible way. We'll need to do this when we start looking at volumes and writing a curve 2 different ways so that we could rotate it 2 different ways to make areas and make volumes and make geometry type objects. So solve for x in terms of y. Y equals 2e to the x plus 1. Okay, well that means if I want to solve for x in terms of y, that's going to mean that half of y is equal to e to the x plus 1, meaning the log of a half of y is equal to x plus 1, meaning that x is equal to -1 plus the log of 1/2 of y. And in general, I'm going to put the number in front of the log just to avoid confusion. Especially if you're not good with your parentheses, that you didn't put parentheses on there. Log of 1/2 y minus 1. You don't know if you're taking the log of 1/2 y minus 1 or if you're taking the log of half of y and then subtracting 1. But it's very clear if you move it out to the front, you don't need your parentheses even. So 5b, I know that these are just mostly logs and exponential, but that's the ones you forget about. Y equals 3 plus 4 log x. That means y minus 3 is equal to 4 times the natural log of x. So I'm going to divide by 4. 1/4 of y minus 3 is equal to the natural log of x. And you know how to get x by itself. We're going to take e to both sides power. So x equals e to the 1/4 of y minus 3. Okay, that's great. Part D is going to be, part C. Okay, the only reason I put this one on here is because I need to remind you that when you take the square root of both sides of an equation, you need to not forget about the plus minus. So if I take the square root of x squared, really what this, and maybe today will be the first time, and it won't be the last time I explain this to you, the reason the plus minus comes in is because the square root of x squared is not x, if you think about it. It's square root of y minus 1 is equal to the absolute value of x, okay? Think about it. If you take the square root of x squared, start with, I'm just going to kind of block this off. Start with 5. 5 goes to the square root of 25, which is 5. Okay, so it didn't change, it's x. But what if I had made that -5? If I take -5 and I square it right there, okay, really it's like I'm taking the x value, I'm squaring it, and then I'm taking the square root. Well, what's going to happen is that's going to become positive 25 when I square it. -5 times -5 is positive 25. And I'm still taking this positive square root of positive 25. So 5 goes to 5, and -5 also goes to 5. That's an absolute value type situation. And when we say that, okay, going back up, the absolute value of x is equal to 10, well, that could be because x was 10 or because x was -10. And that's where we say that's where the plus minus really comes in, is from an absolute value, and that's why I put that elsewhere too. Y minus 1 equals the absolute value of x, meaning that x equals plus or minus the square root of y minus 1. And you probably just got it drilled into you, somewhere along the way. You take the square root of both sides of an equation, you need to remember the plus minus. Now, what you don't seem to have drilled into y'all is what happens when you square both sides of an equation. And there is something you have to think about when you square both sides of an equation, but I'm not going to say it now. If you think about it, try to remember, try to look it up. If you still can't remember what the special thing is you're supposed to think about when squaring both sides of an equation, you need to ask me personally, and I'll tell you about it. Okay, 5D. I'm kind of... what else did I put in here? 1/2 the cube root of 3x. The cube root of 3x? No, just x. All right, so what I'm going to do is I'm going to multiply both sides by 2, so 2y equals the cubed root of x. So I'm going to cube both sides, and I'm going to say x is equal to 2y taken to the third power. You could definitely write that that was 8y to the third if you wanted, but that's the same thing as what I wrote. So 5e, and we don't simplify in this class at all, ever. Log absolute value y minus 1. Okay, this question was written wrong. This is not going to be something you can solve for x. Because of the x squared and the negative x, you'd need to complete the square on x, and that's just not something we ever do in this class. What I actually meant for this to be was to solve for y on this one, because this is actually one that you have to solve for, you know, later on in the course, probably by like October or so. So what I'm going to do is I'm going to solve for y. And I'm going to change it on the statement of the homework so that maybe my B-Day people, maybe they haven't looked at it yet and they just will never know, unless they watch the video. So what I'm going to do is I'm going to get rid of the log, right? So I'm going to say absolute value of y minus 1 is equal to e to the 1/2 x squared minus x. And anybody that was in calculus AB knows like where I'm headed with this, why I'm bringing this up. But I was thinking about like, what are the algebra things we really need to do? And I would say separation of variables could be it, but man, I don't know how I'm going to test you on separation of variables this year, because there's a calculator on the internet for it. So I'll figure that out later. Okay, and then after this, I'm going to just add over the 1 and I'll be done. Okay, and that's the solutions for the first set of practice problems.